Hello everyone, this is the homework video for Im1, homework number 31. Pythagorean theorem. Write the Pythagorean theorem equation for the right triangle, then use the equation to find the missing side x. Round your answer to the nearest tenth if necessary. So what do we have here? Well, first thing is you want to identify the hypotenuse and the legs. Across from the right angle, this is going to be my hypotenuse. That means this is my leg and this is my leg. So leg squared plus leg squared is hypotenuse squared. So it's 10.8 squared plus 6.5 squared is x squared. What is 10.8 squared? 10.8 squared is 116.64 plus what's 6.5 squared? Is 42.25. And if I add those up, I get 158.89 is x squared. So what do I do to find the x? How do I undo squaring? I take a square root of both sides. Squaring and square rooting take undo each other. And so I push this button right here. And that leaves me with x is equal to 12.6005. We want to one decimal place. That means, or 2/10 is, you're going to cut off after one digit after the decimal place. But before you do that, you need to consider the next digit, which is 0. 0 is less than 5. So you do not do anything. You are not rounding up. So it's going to be left as 12.6. Okay. Number 2. Okay, again, we need to identify hypotenuse. This is my hypotenuse. That means these are my legs. So I have 5.5 squared plus 9.2 squared is x squared. Okay, and 5.5 squared is 30.25, and 9.2 squared is 84.64. Now from here I want to add this number to this number. I want to add the previous number 30.25, and that leaves me with 114.89 is equal to x squared. And again, to undo squaring, I take a square root of both sides. When I take a square root, I get x is equal to 10.7 to the first digit. Okay, again, I need to cut off right here after the 7. But before I do that, I need to consider the next digit, which is 1. So 1 is less than 5. I do not round up. I leave it as it is. Number 3. Okay, first identify the hypotenuse. This is my right angle. Across from right angle is hypotenuse. You can't go by where the location is, because the triangle, as you can see, is rotated, which means this is a leg and this is also another leg. So that's going to be 5.4 squared plus 6.5 squared is x squared. Please start by setting up the equation like so. And then from here, 5.4 squared is 29.16 plus 6.5 squared is 42.25. So I add these two numbers together and I get 71.44. Take a square root of both sides and I get x is equal to 8.4. Now I want to again cut it off after one digit. So it's going to be 8.4. But before I do that, I need to consider the next number. 5 is 5 or more. So that means I need to round the 4 up. What is 1 up from 4? It's going to be 5. So 8.5 is my final answer to 1 decimal place. Number 4, same thing. This is my hypotenuse. This is my leg and leg. So it's going to be 4.5 squared plus 5.9 squared is x squared. And 4.5 squared is 20.25. 5.9 squared is 34.81. Add those two numbers together and I get 55.06 is equal to x squared. And then take a square root of both sides to undo squaring, and I get x is equal to 7.4, because when I cut off after 4, 2 is 5 or less, so I leave it as it is. Number 5. Again, identify the hypotenuse. Here's my right angle. That means this is my hypotenuse here. And this is my leg, and this is my leg. Notice that the hypotenuse is not the unknown. Okay, the unknown is one of the legs. So you do need to set up the equation as the leg is x squared plus 10.8 squared is 14.4 squared. Notice that I am starting with the equation. Okay, so then what is, I have x squared. I still don't know what x squared is. 10.8 squared is 1 sec, that does not look right. 10.6 squared is 112.36 is equal to 14.4 squared, which is 207.36. Okay, I don't want x squared plus some number is equal to that, so I need to get rid of this. How do I do that? I am going to subtract 112.36 from both sides. Okay, and when you do that, this goes away to 0, and on the left hand side is you're left with x squared. On the right hand side, you're subtracting from this number minus 112.36, and that leaves me with 95. So I have x squared is equal to 95. I don't want x squared, I want x, so I take a square root of both sides. And when I do that, I get x is equal to 9.7. The next digit is 4, so I leave it as 9.7. Okay? Alright, same thing here. Identify your hypotenuse. Here is my right angle. That means 14 is my hypotenuse. And here's my leg. And here's my other leg. So that becomes x squared plus 10.3 squared is equal to 14 squared. I can't do with x squared yet. What is 10.3 squared? Is 106.09 is equal to 14 squared is 196. So again, I don't want x squared plus this number. I need to get rid of this number. How do I do that? It's adding. So what is opposite? What is undoing of adding? You're subtracting 106.09 from both sides. 106.09. So that this goes away to 0, and you're left with x squared is equal to 196 minus 106.09. And that leaves me with 89.91. And from here, I am going to take a square root of both sides. And I get x is equal to 9.4 4. But notice that the 8 is a number bigger than 5, so I need to round this up. So it becomes 9.5. Alright, so that's Pythagorean theorem. The next sections are sequence and series. It's a review of that. For each sequence, state if it's arithmetic, geometric, or neither. If arithmetic, find the common difference. If geometric, find the common ratio. Well, it's arithmetic if you are adding the same number to each of the previous number to get the next number. What's going on here? 6 to 10 to 14 to 8. What's going on? Do you see that 4 is being added each time? Okay, so that means you have a common difference of 4 and it is a arithmetic series. Next, what's going on here? 2, negative 18, negative 38, negative 58, negative 78. Okay, what's going on here? Negative 58, 18 to negative 38. It looks like you're subtracting negative 20. Or you're subtracting 20. Okay, am I doing the same thing here? 2 minus 20, is that negative 18? It is. So I am subtracting 20 from previous number to get to the next number. That means you're adding a negative 20 to each of the number, right? Subtracting is same as adding its opposite. So it is arithmetic. And common difference is negative 20. It's a negative number because you are subtracting the number. Okay? 4, 8, 16, 32, 64. Do you see the pattern here? You are multiplying by 2, aren't you? Okay, multiplying by 2, multiplying by 2, multiplying by 2, and multiplying by 2. So this is geometric. And common ratio is 2 because you're multiplying by 2. What about this? 4, 16, 36, 64, 100. What's going on here? I am, from 4 to 16, I'm multiplying by 4. And if I multiply by 4 again, I get 30. Do I get 36? I do not. Okay, if I multiply 4 to 16, I do not get 4. So 16 times 4 is going to be actually 64, not 36. If I multiply 36 by 4, it is not 64. So this is not true. Multiply by 4 does not work. Okay? Can I add the same number? 16 minus 4 is 8. 12. And if I add another 12, do I get 36? No, I do not. So I don't have a common ratio and I don't have a common difference. So this is neither. Okay, what about this? Negative 28, negative 8, 12, 32, 52. Seems like, okay, what can you do? What you can do is, first you look for common difference. You get the next value, which is negative 8. Subtract the previous value. That's negative 28. Okay, so negative 8 minus 28 is going to be same as negative 8 plus 28, which is 20. Okay, and so then I'm going to check to see if this is the same as well. Okay, so I get the next value and subtract 12 minus 8, the previous value. So you get the next value and subtract the previous value. So that's minus 8, which is same as plus. 12 plus 8 is 20. So I get the same number. And I check one more. Okay, if I add 12 plus 20, am I going to get 32? Yes. So I know that what I am doing here is adding 20. So this is arithmetic. And common difference is plus 20.